Assalamu alaikum. Dear students, this lab is on manipulating biological sequences that aims to equip you with essential skills focusing on fundamental operations such as reverse complementation, transcription, translation, computing GC content, and creating sequence alignments. Similar to my previous lab, you will delve into the hands-on application of the BIoPython library to perform various operations. So let's start hands-on practice on some of the modules of BIoPython. This code is importing modules and classes from the BIoPython library. This seek is a class in BIoPython that represents biological sequences such as DNA, RNA, or protein sequences. It provides methods for manipulation and analysis of these sequences. Seek utils is a module in BIoPython that includes various utility functions for sequence analysis. It provides functions for calculating GC contents, molecular weights, and other sequence-related properties. Align is a module in BIoPython that includes tools for sequence alignment. It provides classes and functions for performing pairwise and multiple sequence alignments. By importing these modules, you gain access to a range of functionalities for working with biological sequences and perform sequence analysis and alignments in Python. This line creates DNA sequence object using the BIoPython seek class and initialized with the sequence ATGC. The reverse complement method is applied to the DNA sequence object. This method returns the reverse complementation of the DNA sequence. This line prints the results, which is a reverse complement of the DNA sequence. This Python code is demonstrating the transcription of a DNA sequence into an RNA sequence. The transcribe method is applied to the DNA sequence object, which is initialized here. Transcription is a biological process where a DNA sequence is used as a template to synthesize an RNA sequence. In this case, it transcribes the DNA sequence into an RNA sequence. This line of code demonstrates the translation of a DNA sequence into a protein sequence. The translate method, which is here, is applied to the DNA sequence object. Translation is a biological process where a sequence of nucleotides in mRNA is used to synthesize a corresponding sequence of amino acids in a protein. In this case, it translates the DNA sequence into a protein sequence. This code is extracting a subsequence from a given DNA sequence using a technique called as slicing. This line creates a new variable subsequence, that is here, by using slicing on the DNA sequence object. The syntax 2:6 specifies a range of indices from index 2 to index 5, that is inclusive. 6 is exclusive, 5 will be inclusive, to extract a subsequence. In this case, the extracted sequence would be from index 2 to 5, resulting in GCAT, that is here, GCAT. This code calculates the GC content of a DNA sequence using the BIoPython seq utils module and then prints its result. This command is used to print. You have seen this line of code several times in this lecture and the previous one. The GC content is calculated by this function GC from the seq utils module to calculate the GC content of the DNA sequence object. This is DNA sequence object that is initialized in the start of this lab. GC content represents the percentage of guanine and cytosine bases in a DNA sequence. These lines of code are comparing and printing two DNA sequences, seq1 and seq2, using the BIoPython library. Two DNA objects, that is seq1 and seq2, are created using the BIoPython seq class. Both sequences are ATGC, ATGC. This code uses an if statement to check if seq1 is equal to seq2. If they are equal, it prints sequences are equal. Otherwise, it prints the two sequences are not equal. The output in this case will be sequences are equal. Next, this whole code performs pairwise sequence alignment. Two example sequences, that are sequence 1 and sequence 2, are defined. These sequences represent strings of nucleotides. An instance of pairwise aligner here is created. This class is part of the BIoPython align module and is used to perform pairwise sequence alignments. The align method of the pairwise aligner object is used to perform pairwise alignment. This is the align method, that is accepting two sequences as input, seq1 Seek 2. The result stored in the alignments variable. Then this for loop is used to iterate through the alignments generated obtained from the align method, and each alignment is printed. I hope you will enjoy this lab and do hands-on practice on all these operations which are discussed in this lab. Thank you very much.